Assalamualaikum. My name is Muhammad Akmal bin Muhammad Arif. My matrix number is DD240113. So for the theory of the energy conservation, okay, so ideally energy transform perfectly. We start by lifting a weight to create potential energy, and when that weight drop, the energy converts into kinetic energy, and this is split into two types: the linear motion of the falling weight, and then the rotational kinetic energy of the spinning flywheel. So the flywheel is the most important part because of its moment of inertia. It acts like a battery, storing rotational energy to wind the cord back up and lift the weight. However, the weight never returns to its original height. This proves that the real-world system always faces energy loss due to friction and air resistance. Therefore, we calculate this loss by simply the input energy minus the output energy, which is basically the potential energy, the initial height, and then potential energy of the final height. That's it. Thank you.
So this is the result that we get from the experiment. This graph is for load versus energy loss. This graph show positive correlation, and this graph is for load versus height, and this graph also show positive correlation.
Alright, so let's move to the observation. So first, initial height fits. All load released from H1 which is 400 mm. So that's mean all load have a constant initial height. Second is final height always lower. H2 must be lower than H1 for every load. Energy not fully recovered. So third is heavier load which is equal to lower rebound. So as weight increase from 0.8 Newton until 3.0 Newton, H2 will decrease. So yang keempat is energy loss increase with load. So calculated loss which is W dot H1 minus W dot H2 greater for heavier weight. So yang kelima, main cause of loss. First is friction, such as bearing and cord slippage. Second is non-conservative force, which is heat and sound.
For the calculation, to get the energy loss, we will first have to calculate the potential energy of the initial height and the potential energy of the final height. And to get this is we just simply multiply the load and the height. Okay, so for example, the first one where the load is 0.8 Newton. Okay, so 0.8 times 0.4, we will get 0.32 Newton meter, and then 0.8 times 0.06, we will get 0.048 Newton meters, and then we subtract this to value to get the energy loss. Okay, so P potential energy initial height minus the potential energy final height, where 0.32 minus 0.048, we will get 0.272 Newton meters.
For graph load versus energy loss, the graph of load versus energy loss show a positive correlation. As the load increase, the energy loss also increase. Heavier load result in a greater proportion of the initial potential energy being lost. These, these losses are likely due to friction in the flywheel mechanism, air resistance, and inefficient in the energy transfer process. The increasing energy loss with higher load suggests that the system become less efficient at higher load. More energy is dissipated as heat or sun rather than being converted into potential energy. And this is graph load versus height. The graph of load versus height show a positive correlation. As the load increases, the final height H2 reached by the weight also increase. A greater load require more energy to lift it to a certain height. Initial potential energy is partially converted into lifting the weight to H2. A higher load will naturally result in a higher H2, given that more energy is transferred to the weight. The relationship is not perfectly linear. The nonlinear relationship indicates that the efficiency of energy transfer change with increasing load, as seen in the energy losses discussion.
So we move to discussion C, judging for H1 and H2, approximately what proportion of the energy had transformed, stored, and given back. During the motion, the total mechanical energy, sum of kinetic energy and potential energy remain constant. And at the initial height, the potential energy is maximum and the kinetic energy is zero because the system starts from the rest. When the flywheel is released and the wake hook reaches the lowest point position, the kinetic energy becomes maximum while the potential energy becomes zero. After passing the lowest point, the hook weight moves upward again and reaches a new height, which is lower than the original height to the energy loss. So at height, the system contains both kinetic and potential energy since the hook is still moving out, but at a reduced speed. Regarding with the discussion D, which one most contributing for storing and giving back the energy, the flywheel or wake? The values of H1 and H2 indicate how the flywheel converts energy during motion. When the flywheel is released, the gravitational potential energy stored in the raised mass is transformed into kinetic energy. If there are no energy losses, then all the potential energy will be completely converted into kinetic energy, where the mass fall through height. Potential energy formula is PE equal to mgh, and example as position with a load wake of the potential energy can be calculated using the equation above. Move to discussion E. Suggest some cause for the losses in potential energy. The larger the weight of the load, the higher the energy losses. A heavier load creates more friction, such as friction between the flywheel and the clamp pad, and also increases air frictions. Increased friction results in greater loss of energy. Another cause of potential energy loss is the shape of the weight used. Uh, a more dynamic shape reduces air resistance, which decreases energy loss. So a less aerodynamic load shape increases drag, causing more energy losses.
Assalamualaikum, my name is Haikal Amar. I will present about conclusion. In this experiment, we learn how the conversion of energy works in real life. At the start, the wake has potential energy when it is at the highest position. When the wake drops, the potential energy turns into kinetic energy and makes the flywheel spin. The flywheel then stores some of this energy and lifts the wake back up again. But the wake does not return to the same highest position. This shows that some energy is lost because of friction, air resistance, and other mechanical losses. Even though we don't get all the energy back, this experiment proves that energy is converted and stored. It also shows that in an ideal system, energy is conserved, but in real system, some energy will always be lost. Overall, this experiment clearly demonstrates how potential energy changes into kinetic energy and how a flywheel can store and return part of this energy. Thank you.